All right, we are going to go ahead and get started. My name is Sal Stangaroni. I work for TEC in the Controls Department. We represent Carrier Commercial Controls, and today we're going to be talking about the Carrier RTU Open Controller, which is a native Bacnet controller here. So let's jump right in. So the Carrier RTU Open Controller is a Bacnet native DDC controller that is used to control small packaged Carrier rooftop units. Now I say Carrier, but it can also be used to control any small packaged rooftop unit. It can control Train, York, anything that has a thermostat terminal board. Okay, so when talking about Carrier rooftop units, it would be the product line, the 4850 TC, HC, or LC, going up to 28.5 tons. And you can get these controllers factory installed. That would be something you talk to your salesman about. And it will come standard with all of the sensors and everything wired that you need, except for a space temperature sensor. Obviously, you can't wire that in. But you can also retrofit these on existing Carrier rooftops, or you can just field install them on new Carrier rooftops. And we can provide a wiring harness for you to do that, which I'll show you a little bit later here on what it looks like. Just a couple features of the controller. It can support up to 2 stages of heat, 2 stages of cool, full economizer, and power exhaust. Sorry, that got cut off there. I'm not sure how many of you guys are familiar, but the new Carrier rooftops are coming out with 2-stage fan control, where you would purchase a Carrier rooftop unit with a VFD on it, and it would be able to stage the fan for first stage cooling, second stage cooling. All of that logic is built into these controllers. There's nothing custom you have to do to it. It will just come ready to go. It's an option you'll select, and we'll look at that a little bit later here. I mentioned originally that these controllers are native Bacnet. That's Bacnet MSTP. But they can also speak Modbus, N2, and LAN. The native board can speak Modbus and N2 just right out of the box, but in order to speak LAN, you actually need to get a separate card to translate to LAN. And the reason we do that is LAN is a proprietary network, and they will charge you for a translator to speak on their network. And we didn't want to include that cost in our boards by themselves because not everyone needs LAN. So, and just a little note there, it supports airside linkage. That's Carrier's communication for VAV type and VVT zoning systems. We call it linkage. We'll discuss it a little bit later when we go into the actual programming. If you guys have questions throughout the entire presentation, please feel free to type them in. I'll try to get to them while I'm doing it. Otherwise, I'll get to them at the end. But this presentation is an actual programming presentation here. So we're just going to be real quick going through the overview of the actual controller, and then we're actually going to get into configuring and programming it. So I just got a couple more slides here. The next slide I have is the minimum requirements that you need for one of these RTU open controllers if you want to field install it. Okay, this comes up a lot where we run into situations where someone just wants to purchase a controller and throw it on there, but the controller itself cannot function properly unless it has these sensors here. So all of the Carrier controllers, including this RTU Open controller, require a dedicated transformer. Okay, you will lose your warranty if you do not have a dedicated transformer. You need to have one. The controller itself will not be able to function without a supply air or a space temperature sensor. Okay, these two sensors are critical for the logic to actually function. Now, because these boards are Bacnet native and they can be integrated into other control systems, you can actually use a supplier temperature or space temperature sensor from the building automation system, meaning it doesn't have to be hardwired to the controller. You can actually take that point up via the network, but it somehow needs these values in order to function. It cannot go through its logic to control the rooftop without them. Okay, so that's bare bones. If you need that controller to function, you need those two sensors and a dedicated transformer. And then also we do include with these rooftop controllers a wiring harness of how it wires into the thermostat terminal board, which I'll show you on the next slide here. But that's kind of a side note. We just include those always as standard. So here we have an example of a wiring diagram that we would either provide to you if you requested it, or you can see something similar to it in the installation manual that we'll look at. But you can see there's the controller here. You guys can see my hand on the screen there. Let's see if I can get a pointer going. So this is our rooftop controller. All right, sorry, I'm not the best drawer. But up here would be the rooftop thermostat terminal board. You can see you got R, common, Y1, Y2. There's actually a Molex plug on our controller. If I scroll back a few pages here, you can see this white little dongle here. This is a Molex connection from our rooftop controller that we provide a wiring harness to that plugs directly into there and can wire to the thermostat terminal board. So if we look again, we have two Molex plugs, and they connect. You wire right to the the RTU thermostat terminal board, your common, your G, your Y1, your W1, and then you have all these other sensors. Not all of them are required, but these would just be options of how you can wire them in. So you see we have an enthalpy switch for outdoor air lockout. We have an outdoor air temperature sensor. We have a supplier temperature sensor. And then we have a current transducer for fan status, and we actually wired to the economizer actuator here. So just kind of a general layout. We can provide these for you if required. Most of this stuff will be factory wired if you get the factory installed option. So this would only be for a field installed option, but something that we just do standard whenever requested as a policy here at TEC. So with that, we are going to get into the actual programming of the controller. So I'm going to close this down here real quick. Actually, really quick before that, I'm just going to show you there's two guides for using the RTU Open controller. So we have the RTU Open integration guide, and we also have the RTU Open installation guide. Okay, they're both a little bit different. There's a lot of similarities, but because a lot of these RTU Open boards get integrated into third-party building control systems, we provide a separate manual that has all the installation points and the configuring for setting it up to run with, say, LAN or Modbus, something similar to that. So with that, we will go through the software. So the carrier's software for commissioning these controllers is called Field Assistant. Okay, this is something that we can sell to you. Comes with the software, and it also comes with a cable, which is a USB that connects to your computer and can plug into any carrier open controller. And what this software allows you to do is it allows you to communicate with the controller that you're plugged into, but also communicate with any other carrier controller that is wired into the network. The communication bus for that system. Okay, so if I have 5 carrier rooftop units wired together, if I plug this this Field Assistant software into one of the controllers, I can actually see and configure all 5 rooftops from just one location. And to go one step further, if you provide a carrier communicating sensor along with those rooftop controllers, you can actually plug in locally to that sensor. You do not have to plug in at the controller itself on the rooftop. So kind of a nice little deal there. But with that, just basics here of what we're looking at. So this top portion where it says web demo, this is actually the storage of your databases. So a database is the data that gets stored from the controllers for specific jobs, okay? So for this job, we want to create a new database. What we would do is we'd hit this plus sign right here, and we would type in a system name. Right now, I'm just going to do web test. Type that in. I would hit create. Now it's creating a database so that everything that I see and upload from these controllers will be stored on that database on my computer. Now these databases can be shared between separate computers, right? So let's say that I was at a job site and one of my technicians needs to go out there the next day. I can actually take this database from my computer, give it to him. When he goes out there, he can plug into my controller. Everything will be already stored on his computer. He can pull it up very easily, okay? So it's a nice feature to have, especially because all of Carrier's control programs are actually stored locally on their controllers. So in order to access them, you have to upload all of that control data to your computer, and it is a little bit time consuming. It can take approximately 5 minutes to upload one single controller. And because of that, if you already have the database stored on your computer, it's very easy. You can just plug in and everything will just auto-detect. There's no extra upload time here. So now that I created that database, you can see that it's stored in my system name here. I can choose my time zone. This is important because if you do a time sync to set up your time zone, you need to have the right time zone. You don't want to be programming Eastern Standard Time out in Chicago here. That's not going to help you out with your scheduling. So the next thing to look at would be these communication radio buttons. This communication radio button would be if you're trying to communicate through the Ethernet connection, which is something that we do not offer with our field assistant. I think it's only available for future connection here. So you would always want to make sure you check this box which says COM, and then it'll give you a port. Okay. Now this is referring to the USB port that you actually plug in this USB converter to. Okay. So if I go to my computer, if I go to my control panel and I go to Device Manager, the screens will look a little different if you're not using Windows 7 here, but under Device Manager you're going to see let's see if I can make this bigger for you guys here. You're going to see a drop down that says ports, and you're going to see the different ports that are connected to your computer. So you can see I have COM 3, 4, 12, 5, 6, and 7. Okay. The communication that I am locally plugged into is the COM port that I want to choose in order to talk. And what shows up when you plug in Field Assistant in your computer is this Silicon Labs CP210X USB to UAR bridge. Okay. So when you first start up your Field Assistant, you want to select the port that you're plugged into. You can go to Device Manager and you can double check to see which COM port you're plugged into. Okay, so right now I'm in COM 12. Now that I've confirmed that, I want to go back to my Field Assistant. I would select COM 12. Okay, so once I have my COM port selected, I have my database set up, my time zone set up, I'm going to hit this green play button. Okay, now one thing to note is in order to run Field Assistant, you need Internet Explorer, okay? And it can only run through Internet Explorer. That is the only way to do it. If you do not have it, you will have problems, okay? So you need to make sure that you download it. But like I said, I just hit the green button there. It will auto-load Internet Explorer here. And you can see I have an immediate error in red here. It says the controller has not been uploaded. Please upload to update files in the system, okay? What that means is since I started a brand new database, I don't have anything stored on it, okay? And I'm plugged into a controller, and I need to take the data from that controller, bring it to my computer so that I can read what's going on there, okay? And the way Carrier's lingo goes is if you want to take something from the controller to your computer, you're going to upload it. If you want to take something from your computer and put it on the controller, you're going to download it, okay? I know it's a little bit reversed from actual internet to computers, but that's just kind of how they go about it. So what I would do is if I was just starting this system, I would hit upload and I would try to upload this controller to my network. Okay, I'm sorry, to my computer. Now you can see on the left hand side here we have this tree and it's going to show you controller 1. Okay, this is the controller that I'm locally plugged into. If I had more than one controller wired together on my communication bus, there would be more controllers showing up on this network. And this number 1 is actually the local address on that controller. Okay? So if I go back to my installation manual, or actually my integration manual, if you look at the Rooftop controller, scroll down a couple pages here, each controller, I mean, depending on how familiar you guys are with communication systems and controls, each controller has to have a baud rate and an address, okay? And all of these, both those configurations are actually hard set on our controllers. So if you look at these two red boxes here, we have two rotary addresses for setting the address of our controller, okay? So if you wanted to address it as 99, you would set the 10's digit to 9 and the 1's digit to 9, okay? Each controller on the communication bus can go up to 99 addresses, okay? So locally, in order to communicate, you have to first set each of these rotary switches to the address you want for each card. If you have the same address on two cards wired together, you're not going to be able to communicate. You're going to run into big issues, okay? So each controller has to have an individual address. Okay, and then the other part is this dip switch down here, which allows you to select the baud rate. It also allows you to select what type of communication you're doing, if you're doing Bacnet or if you're doing Modbus or N2. So in this integration guide, there's a manual. It tells it tells you which dip switches need to be where. So for instance, we're looking at this example for Bacnet MSTP and a baud rate of 76.8. You need 1 and 2 to be switched on and 4 to be on. That is it, okay? So when you're setting this system up to integrate into another system or to set up your carrier system, you want to look at the integration guide and confirm that your dip switches and addresses are set properly. If you guys have questions on it, you can always give us a call. We'd be happy to help you out. But if you have different baud rates on different controllers, you're not going to be able to communicate properly either, because they're going to be trying to talk at different speeds. It's going to mess up your network, and you're not going to have success. Okay, so these are two critical things you want to do and set before you actually start programming and commissioning your controller. Okay, so I've set my controller locally to address 1, and I'm actually at baud rate of 76.8. What I would do next would I would hit upload. Okay. Now, because it could take up to 5 minutes to upload this controller, I've actually already uploaded it on a different database, so we're going to go there real quick, okay? So I'm going to close out of this guy. I'm going to hit this red stop button, okay? That means I want to stop talking through the USB port, through Field Assistant. Once I hit stop, Field Assistant's going to come back up. Sorry that you guys have to see all my icons on my desktop there. And now I'm going to select the database that I've already stored, okay? So I have a bunch of them under here, but I just set one up as web demo. So I'm going to select that. I make sure I'm on COM12. I hit my green play button. And Internet Explorer is going here. Okay, so you can see it looks a little bit different now. It actually says RTU open instead of controller 1. Why it says that is because it actually can read the program now that I've taken from the controller on my system, my database, and it knows it's an RTU open program, okay? So that's why it says RTU open there. If I click on this network, first off, just general basic Bacnet protocol is you need to have a network, and then you need to have a network number for each, you have a network number for your entire communication bus, which for carrier it defaults to 16101, and then you also have an address that we talked about before, which would be 01 for us now for this one controller. So this is defaulting as network 16101. That's only on the carrier side. If you're wiring this into, let's say an ALC network, they're going to have a different network number, okay? So it's not that big of a deal, but when you see it, you should always see 16101 or 16 and then some other numbers if you're viewing it on Field Assistant, okay? So if I click on my network and I'm on the Discovery tab, this is where I can see where all of my controllers are, okay? So if I had more controllers than just this one controller wired in, I would see a whole list of them and their addresses, their names. I can actually name this controller. If I want to name it RT1, I would type that in and hit enter. And if I give it a minute, it'll actually load that on the left-hand side, okay? It's going to tell me the model of the controller that I have. So I have an RTU open. If, for instance, I had a VBT controller, it would say VBT open on there. And then it's going to tell me my version and my view file. My view file is actually my graphic, and my version is the version of the program on there. So Carrier releases updates to all of their control programs. They do it whenever they come up with, they fix a bug or anything that's out there, and they'll actually release different versions. So if you want to confirm what version rooftop unit that you have, what control program you have, you would come to this network discovery, and you can look at what version number you have. Once you have that version number, if you see it's out of date, you can actually update that version to the new version. So, other than that, we can see what we've got here. If I hit check status, it'll just check to make sure that I'm still communicating with this. And if you see a check mark, that means you're communicating. If you saw some red error that said communication error, that would mean that something is not connected and you're not communicating with it, so you won't be able to access it. So if I want to go back to the actual RTU Open Control program, on the left-hand side here, I would click on the RTU-1, and now you can see I have a graphic file. Okay, so this is my view file. This is exactly what is going on with my controller, just kind of a general graphic status, right? So you can see I have a filter, a DX section, a fan, an electric heat exchanger, and then I've got some temperatures, okay? This is a brand new carrier controller, okay? All of these rooftop controllers come standard with their RTU Open program on it. So all I did was upload this. I didn't add anything. I just hit upload, and this is what showed up right out of the box, okay? Now, we might not be controlling a unit that has DX cooling and electric heat, but it still comes standard on the program. That's something that we're going to configure, or we call program, for our specific application, okay? So we're going to go into the actual programming now. You can see along the top I have different tabs here. I have graphics, properties, schedules, trends, reports. We're really going to only deal with properties and properties and schedules here, but in order to do the configuring, we need to click on the properties tab. Okay, and if you'll notice now we have 6 more tabs here. We're going to go into each of them individually real quick, but we're going to always start off on the equipment tab because that's where you actually do the configuring. Okay, so I have some drop downs here. I have a status drop down. If I look at it, it will tell me what my unit's doing currently. So right now my equipment status is disabled, it's not functioning, I'm in shutdown mode, and you can see I have a space temperature value reading of minus 56.2. That is a crazy value. I do not have I'm not reading 56.2 degrees Fahrenheit. That means I do not have a sensor wired in properly, okay? So I also don't have a supplier temperature sensor, I don't have an outdoor air temperature sensor, okay? This is just a general status view. If you wanted to see an update, most of this stuff can be seen on the graphic like we saw before. You can see I'm in shutdown mode, negative 56.2. And I have these red boxes around these items. If you ever see a red box, that means there's a problem with that portion of the controller, right? So I have a problem with my space temperature sensor. I have a problem with my supplier temperature sensor. And you can see I'm actually saying I'm in shutdown mode for space temperature failure, okay? So we need to configure our unit so it can function properly and so we can get past these values, okay? I'm sorry, these alarms or errors. So I go back to properties, I'm on equipment, I want to go to configuration because I want to configure my unit, okay? I have 4 different drop downs here. Each one is relatively important. The big ones are unit configuration and service configuration, but we're going to go through all 3 of them here real quick. And just so that you guys know, all of these drop downs and these configurations we're going to go through are in the installation manual. Okay, so if I go back to my installation manual for the RTU Open, I'm going to open it up here. I think it's page 62 maybe. Yeah, you'll see here, this is Appendix A of the installation manual. You can see that I have each of those drop downs. So I have status right here. It will tell me the different statuses I can have and what they mean, what I configure them for. I have unit configuration like we saw, all the different inputs that you can change. I have set points. I have alarm configuration and service configuration. Okay, so if you ever have a question or you forget what we talked about here on one of these tables, you can reference the installation manual to see what exactly you need to set for that specific item. Okay, so we're going to start with unit configuration and work our way down. Okay, so the first thing we see is fan mode. What fan mode means is how you're actually going to run your supply fan, okay? And there's a couple different options. See fan mode right now we're set for continuous. This drop down is going to tell me what options we can do here. So I have 3 options. And again, you can reference what these options mean in the installation manual, but I have auto, continuous, and always on, okay? We'll start with always on. Pretty straightforward. It means no matter what the unit's doing, if it's occupied or unoccupied, if it's heating, cooling, or just running fan, it's always going to be running the fan, okay? It's going to run 365 days, 24/7, always on. That's what that means, okay? Continuous means that I'm always going to run the fan when I'm in occupied mode. Okay, so when my schedule says I'm occupied, I'm going to be running the fan. No matter if it needs heat or cool, or if I'm satisfied, my fan's still going to be running. And then the third option, auto, means that I will only run the fan when I have a call for heating or cooling or economizing. So whenever my space temperature is out of whack and I need some air, I'm going to turn my fan on. Okay, you can select which option you want. You can confirm it with the end user, or if you're the end user, you can select it, but we give you the option of how you want to control that. Okay. There's a couple different safeties here. Power fail restart delay is just a 5-second restart delay if you lose power. My fan off delay is if my fan's off, I'm going to wait 90 seconds before I turn my fan back on. You can mess with those. I usually just leave them as defaulted because that's what Carrier recommends for their units. Couple items we want to look at that are kind of important here are the minimum cooling supplier temperature and the maximum heating supplier temperature. Okay, so I can type in and change these values to what I want, but we default to 50 and 120. Okay, so if you unfortunately have an oversized rooftop unit and you're getting discharge air below 50 degrees, you're going to want to lower this value. Okay, so I can just click on that number and I can type in, say, 45 degrees, and that will switch that value. One thing to note overall is any change that you make, you notice I just typed in 45, you'll see these boxes come up, these OK and cancel. I have to click either OK or cancel before I can try to move to a different screen, okay? So if I wanted to go back to my network screen on the left here, if I click it, it's going to say, nope, you need to hit OK or cancel in order to make your change, all right? So I want to change this to 45 degrees for my minimum cooling supplier. I need to hit OK. Once I hit it, it'll disappear, and I'm good to go. I can switch screens. If I want to change my maximum heating to, let's say, 95, I'm going to type in 95. Let's say I don't want to change it. I just typed it in wrong. I can hit cancel, and it's not going to take that 95 degrees, okay? So it's just something that you have to remember. If you ever get stuck and it says, please click OK or cancel, you got to hit OK or cancel. So moving forward here, we got a supply fan service alarm timer. These are options for the mechanical contractor who does the installation to, or even the controls contractor, but to set up alarm timers to go off whenever you need to do maintenance, okay? So let's say that you wanted to maintain the supply, or you wanted to do a service call every time the supply fan runs for 600 hours. If I type in 600 here, once that timer, if I type in 600 and I hit OK, my timer is going to start running, okay? Once that timer expires, I'm going to put an alarm up on my graphic that's going to say supply fan service alarm, okay? This is more if you actually have a carrier control system set up and you're not tying into a third party, but it's just an option that you can put in there if you want to make your customer aware of maybe they need to look at their service, their supply fan, and maybe change the belt every 600 hours or so. And you have that with the compressor and the filter as well, okay? So one thing to note is if you're commissioning one of these controllers and you're doing it into a third-party system, you want to take these values and you want to send them to 0, okay? Because you don't want your controllers and your alarms and timer alarms interfering with the third-party building automation system, okay? Because you don't want them to see this Bacnet point of, I have a filter alarm, but there's really nothing actually confirming that your filter is an alarm. It's just a timer that went off. So I usually try to set them at 0 unless I talk to the controls contractor about it and tell him, hey, this is going to go off every 600 hours. Do you want to set it for that? And he'll say yes. Okay. So I like to set those all at 0, one for compressor, one filter, one supply. If I keep scrolling down here, we have push button override. This button is for if you have a space temperature sensor with a push button on it for overriding the schedule. Let's say that you have occupants who stay late and your schedule goes to 7 p.m., but they're in there at 9 p.m. and they're getting kind of cold. They would push this button on the sensor and you would go into occupied mode. On our controller, you can actually disable this function. So you can allow the end user, if he wants, to be able to push the button and think it comes on, but it won't. But that's purely up to you. as to if you want to give them that option or not. Cooling lockout temperature. Right now it sets it up for 45 degrees. On all carrier rooftops, the compressors have a mechanical lockout at 45. So regardless of what you type in here, if you type 0 degrees outdoor air on this, your compressor is going to lock out mechanically below 45 degrees. But what this value helps you do is if you, for instance, don't want to use mechanical cooling below 50 degrees and you only want to economize, you can set this to 50 degrees and my compressors are never going to come on. I'm only going to use the economizer. Okay? So that's your lockout temperature for cooling. Heat pump reverse cycle lockout temperature. I've never installed one of these on a rooftop heat pump. I've never even seen a rooftop heat pump. But that's your delta for locking out your heat pump, your reverse cycle. I've honestly never seen it, but if you want to type that value in, you're more than welcome. It's not going to do anything unless you have a heat pump and reversing valve set up. You also have a heating lockout temperature on here. You can see that defaults to 65 degrees. That is, you don't want to ever allow heat above 65 degrees, only below it. That's adjustable. Your minimum set point separation. This is an important value here, okay? This 5 degrees this is the delta between your heating and cooling set point, the minimum delta that you can have, okay? So, for instance, if I have a 70 degree occupied heating set point, the lowest occupied cooling set point I can go to is 75 degrees because I have this 5 degree minimum set point separation, okay? So if I want to bring that heating and cooling set point a little bit closer, I first have to adjust this value to, let's say, 2 or 3 degrees before I can actually make the change on my set point. If I change it on my set point locally, it will not adjust that value. We can look at it here real quick. So if I go to my graphics page, on the bottom here I have my occupied set points, so you can see I have heating and cooling of 70 and 76. If I hit this little arrow here, this allows me to type in my occupied heating set points. So we just set the minimum set point separation at 70 degrees. Let's say I want to change cooling to 71. If I type that in and I hit OK, it's not going to take. It goes right back to 76. Okay? That's because it will not allow you to go below that minimum set point separation. First you need to change that, then you can adjust your set points. Okay? So going back here, we're going to go to Properties, Configuration, Unit Configuration. And we are down to another important one, Occupancy Source. Okay? If I look at my drop-down, I have 4 different options. I have Always Occupied, which means I will run 365 days a year, 24/7, no matter what. Okay? No schedule, just cranking all the time. Generally, you'd use this if you're doing like a server room, maybe. But you don't really want to be controlling a rooftop unit. You don't really want to be controlling a server room with a rooftop unit in the first place. But that would just be an example of how you can use it. The 3 other options you have are Bacnet Schedule. Okay, what this is if I put a local schedule on my controller through Field Assistant, if I went to the Schedules tab up here, it would run off this Bacnet Schedule. Now that schedule is actually writable via Bacnet. So my third-party building automation system could actually write to that schedule and say, Monday you're occupied from 7 a.m. to 8 p.m. or Tuesday you're occupied 7 to noon. That would be one option of controlling when the unit goes into occupied mode. Just general overall occupied versus unoccupied is just for general standard night setback. And what it does is you have set points for your occupied period and you have different set points for your unoccupied period. So for energy savings, if you want to maintain 70 degrees and 75 degrees when people are in the building and it is occupied, those would be your occupied set points. If you just want to maintain the building at 60 degrees and 80 degrees during unoccupied periods, you would set it up so that it had those broader set points. I think everyone's probably familiar with that, just a general, just in case. So we've got Always Occupied 365 days a year. We have Bacnet Schedule, where it runs off the schedule that I can put on it on Field Assistant or the schedule that a Bacnet third-party control system can write to it. The third option is BAS on-off. This is a lot easier to use with a third-party device, third-party control system. And what it is just a Bacnet point or Modbus or LAN point that the building controls contractor can just write through the network an on value to that point, and the unit will go occupied. So this allows your building automation system to do their own schedule on their side. Whenever they go schedule, they can just write to this point and turn the unit on or off. Whereas with the Bacnet schedule, they'd actually have to write Tuesday you're occupied from 7 to 10, Wednesday you're occupied from this to this. So this is a little simpler and cleaner for the building automation system. And then the final one is remote occupancy input. This is basically the same as the BAS on-off, except it's actually a hardwired point. Okay, so this is a closing contact that you hardwire into the rooftop controller, the RTU open controller, and when it reads closed, it reads that the unit goes into occupied mode. Okay, so some people like hardwire versus the network. Doesn't really matter to me. I mean, both of them are going to turn it on. So that's the first part of unit configuration, setting up your your limits and how you want the unit to run. I'm actually going to set this up at Bacnet Schedule here. Hit OK. Now I want to configure the inputs for my rooftop unit controller. Okay. Like I mentioned before, to run this rooftop controller standard bare bones, you need a supplier temperature sensor and a space temperature sensor, and then your transformer. Other than that, you technically don't need anything to run it. It will run by itself. But there's other options you can do based on what type of unit you have. So if you have a humidizer or doing dehumidification with the rooftop, you would require a humidity sensor to read to maintain that set point. Okay. And all of these inputs are what you're actually telling the controller what type of sensor you have wired in. Okay, so these inputs 1, 2, 3, 5, 8, and 9, you can actually see if I go back to my integration manual here, zoom out a bit, this will actually tell you the different input locations. Okay, so if I look on J5 over here, I have input 8, input 5, input 3, all input 9, all in this plug. Okay, so if I, for instance, wanted to wire in a humidity sensor, I would have to wire it to one of these inputs. Then I would have to tell the controller, you have a humidity sensor wired into this specific input, so it knows where to look for its value. Okay, all the logic to control with humidity or CO2 is all standard on the rooftop controller. You just need to tell it where that actual sensor is wired into so it knows where to look. Okay, so if I go back to our field assistant here, I have input 1 has a couple different options of what you can wire in. Okay, you can wire in an indoor air quality sensor, an outdoor air quality sensor, or a space relative humidity sensor. Okay, those are the only 3 options you can wire into that specific input. Okay, that's just how the controller is configured and programmed from the factory. Those are your only options. So for IAQ sensor, that would be an indoor CO2 sensor. An OAQ sensor would be an outdoor CO2 sensor, and then space relative humidity would be space humidity. Each of those sensors can be a 4 to 20 milliamp or a 0 to 10 volt DC input. Okay, and those are your 2 options for inputs 1 and 2. Okay, and the manual tells you which inputs can take what type of sensors. So 1 and 2 can take 0 to 10 or 4 to 20. 3 through 9 can only take closing contacts. Okay, or 24 volts. So if I have a compressor safety, I could put a safety on my compressor. Say I can put a current transducer to prove that my compressor's on. I can wire that in to input 3, and then I would tell it I have a compressor safety on there. Now, whenever that current transducer reads off when my compressor's on, then I'm going to go into alarm because I know to reference it. None of these inputs are factory installed other than the enthalpy switch. That is the only one that you can actually get factory installed on this RTU open controller. I take that back. I think you can get a return air CO2 sensor actually wired in, which would count as IAQ sensor here. But something to note is, like I mentioned previously, this RTU open controller I literally just took out of our warehouse, brand new, uploaded it. It comes defaulted with these inputs set up: compressor safety, fire shutdown, enthalpy switch. these sensors are not actually tied into it. This is just how the RTU Open Controller program comes from the factory. So I need to tell it, hey, I don't have a compressor safety, or I don't have fire shutdown wired in. It doesn't know. It thinks it has it. So what I'm going to do is, if I hit this drop down, I'm going to hit no function for input 3 because I don't have anything wired into it now, okay? And I don't have fire shutdown wired in, and I don't have enthalpy switch or humidistat, okay? But if you can look at the different options of what you have, fire shutdown, fan status, filter status, remote occupancy, or door contact. Remote occupancy is, we talked about the occupancy source. If you choose remote occ input, you actually have to tell the controller what input to look at for that remote occupancy. There's one in the install manual that says to use standard, but you can actually use any of these 3 through 9 inputs. And then one other thing to look at is for this input, you can actually tell it if it's a normally open or normally closed input. Okay, so if you wire an enthalpy, or if you have a fire shutdown that's normally closed, wired in normally closed, if I leave this as normally open, I'm going to read that I'm in fire shutdown because my contact's going to be closed. I need to make sure that I switch this to normally closed, or else I'm not going to be able to run the unit because I'm going to think I'm in fire shutdown. Okay? I'm going to hit cancel here. The last thing in unit configuration is the space sensor type. Okay? These RTU opens can take 3 space temperature sensors, right? And if we look at them, we've got a T55, a T56, and an Spt sensor. Okay? A T55 is just a 2-wire thermistor sensor. Okay? Has to be a 10K Type 2 thermistor, wires directly into the RTU open on 2 terminals. Okay, I think we can look at it here on the install or the integration. It would wire into input 10 on this sensor. I'm sorry, on this plug. It actually says a T55. Okay, a T56 is a 10K Type 2 thermistor, but it also has a slide bar for 100K potentiometer. So you can do set point adjustment with that, okay? So if I wanted to give, again, this is all depending on what type of sensor you have in the space, I can select T56, and then I would look at my install manual of where I would need to wire in my T56 sensor, okay? The final sensor you can get is an Spt sensor, which is a carrier communicating sensor, okay? Now this sensor is a 4-wire sensor. It wires into the plug called RNet on J13. Okay, it's a 4-wire sensor. You can use normal thermostat wire, 18 gauge is fine. But there's 4 different types of these Spt sensors. They all wire the same, but there's different options. So the first option is just a standalone sensor, no display, no set point adjustment, no override, nothing. Okay. The next upgrade from that would be no display on the sensor, but you have a manual override button and you have a slide bar button, okay, for adjusting the set point. Again, wires just with the 4 wires. The third option is a digital display that gives you set point adjustment and manual override, but it also lets you see the space temperature and see your set points. And then the final option is only used for unit vents or fan coils where you actually have multiple speeds of a fan. And it's a digital display that can let you change set point adjustment, manual override, and then it'll also let you bump up your fan speed from like low, medium to high. Okay? So once I've got that, this box here is if you have a T55 or T56, those sensors come standard with a little button for manual override on it. If you click that button, it will go into override for this 1 hour. So you can actually tell it how long you want the override duration to be. So if I want to give them 3 hours, I would just type in 3 here, then I have 3 hours of override time, non-occupied time, switching to occupied. So this sensor calibration, this is just giving you supplier temperature reading. I don't have a supplier temperature sensor wired in right now, so I'm reading 0, but you can just use it to calibrate it if you want to change it. Usually, I mean, our supplier sensors have to be 10K Type 2 thermistors, so with thermistors, you usually don't have to calibrate them. So it's there if you need to, if you have a messed up thermistor, but I would just recommend replacing it with how cheap they are. So I'm kind of running a little low on time here, so I'm going to go into my set points tab real quick. You can see, like we saw before, Carrier likes to do their set points and space temperature with a color scheme here, okay? So I have green, which is my ideal set point value range, right? So right now I have 70 to 60, I am green. Anything left of that will be blue, dark blue, and then red is an alarm, and anything right of that is yellow, orange, red is an alarm. So kind of blue is cold, orange is hot. It's kind of the general idea here. So these different bars actually represent different levels, right? So right now I'm clicked on this fourth bar down, which is my occupied level, right? If I go one below it with this gray bar, this is my unoccupied set point level. So you can see my unoccupied is 55 and 90. You can make these changes like we did on the graphic originally, but this just allows you to do it a little quicker, and you can actually make changes to the different color ranges. So if I wanted to say, right now I have a color range in this yellow where I have 76 to 77, I want to be in the yellow range. I can actually broaden that and make this 76 to 80, I want to show yellow, and then you can see it slides over for all of them here. So the color scheme is just kind of something for the customer, the end user, to see, where they can say, hey, I'm yellow, that means I'm just a little bit warm, where they don't actually have to look at the specific temperature. They just get a general gist of the space based on color schemes. They're all adjustable, all the different ranges, so you can set them up to whatever you want. The three bars on top of here are actually set up for demand limiting or load shedding. What that is if you are reading on your building automation system, for instance, the power metering or the peak loads that are coming into your building, right? You can actually read those values and broaden your set points based on when your loads are peaking. So in order to save save money whenever you're spending most on energy, you want to broaden your set points so that you don't use the equipment as much and you don't use as much electricity. So you have three different levels. I have demand level 1, where I have broader set points, demand level 2, and demand level 3. Now you need a separate program to do this demand limiting, to read the power coming in and to load shed with this controller. But the controller program is set up ready for it on the rooftop unit. You just need a separate program to say, hey, I'm on peak load 1, you go to demand limit 1. I'm on peak load 2, go to demand limit 2. So it's a great energy saver if you're actually doing the power metering, but that's something you have to do separate. Okay. Scrolling down, I wouldn't mess with all this stuff. You kind of want to leave it how it is. One thing to look at would be optimal start. Okay. Optimal start is a feature that comes standard on all carrier controllers, and what it is it's a calculation for when the unit should act, for how long it takes the unit to reach its occupied set points once it actually goes into occupied mode. So when I switch from unoccupied to occupied at 6 a.m., my unit is going to start calculating at that time how long it takes to get the space temperature back up to its set point. And once it does that, it uses that value and it learns and tries to start the unit a little bit later. So it's a built-in energy saver, so you don't actually have to start the unit 2 hours before to guarantee you're back to the space temperature. If you enable this, it will start the unit as close as it can to the actual start time so that you can get back to the space temperature by the time you go into occupied mode. Okay? It's built in and standard on any unit. If you don't want to do it, you don't have to use it. You can just put this value at 0 and change this to none. That would be the easiest way to shut it off. I know a lot of times third-party building automation systems have their own optimal start that they use, so you can lock it completely out. Okay. The last thing on the set points would be the power exhaust set point. These controllers come standard to run power exhaust, and it runs based on the economizer position, your outdoor air position. Okay. So whenever my economizer reaches 50%, then my power exhaust turns on. So I can change this set point to whatever I want. If I wanted to do whenever my economizer is at 10% open, my power exhaust goes on, I would type that value in. Okay. The K factors I wouldn't mess with. That's for the optimal start, so you can leave those alone. Alarm configuration is not that helpful right now. It's something that you kind of just want to default. We'll go into the alarm sources tab to show you a little bit more information on that. But service configuration is the other big one that you want to look at here. So this is where you tell your unit what type of unit you have. if you remember when we looked at the graphic over here, we saw we have 2 stages of electric heat, DX, no economizer. We're just recirculating air. If I go into Properties, Configuration, Service Configuration, now this is where I tell the unit I have heating and cooling or I have heat pump control. That would be my first one. I can tell it how many stages of DX it has. So let's say I want to switch to 2 stages. If I switch that and hit OK, it's going to show up as 2 stages. If I go back to my graphic, now it's going to auto-generate the new graphic where I have 2 stages of compression. Okay. All of the logic and graphics are already programmed on the unit. You just need to configure the unit so it knows what it has. Okay. You're never, even from the factory, you might not get the unit generated what the actual, you might not get the graphic generated what exactly that you have physically, so you need to make these changes on the service configuration table. So I have 2 stages of DX. I want to add an economizer, and I want to add 2-speed fan control, and we usually have gas rooftop units with 2 stages. Okay, so I want to hit OK here. If I look at my graphic, now you can see I have an economizer. You can see my 2 dampers. I have 2 stages of DX. Now I say gas, and I have my outdoor air temperature for my economizer monitoring. You can see I have low enthalpy as well. The carrier rooftop unit control for economizer is supposed to run off of enthalpy. If you don't have an enthalpy sensor, it can still run. You just need to make sure that that value reads low so it'll run off temperature the whole time. But its standard comes from the factory ready to go reading off of enthalpy for outdoor air. Let's say that I configured I want to do demand control ventilation or relative humidity control. I would have to enable these 2 devices here. I hit OK. And now I will be monitoring my relative humidity and CO2. What I forgot here is I actually have to put the inputs for those values as well. So if you remember in Properties, Configuration, Unit Configuration, you actually have to tell it where it has its sensors. So I want to say that I have an IAQ sensor and a relative humidity sensor because I have a humidizer and a CO2 sensor in the space. So I hit OK. Now if I look at my graphic, it's going to show up with, it should show up with it. Let's go back here real quick. Made my first mistake, guys. Sorry. It says I have relative humidity control. It should show up with reading parts per million on this graphic. Well, I'll have to double check it. Maybe this unit needs to be updated with the newest driver, but it should show an IAQ of parts per million of 0 right now because I don't have that, and you should be able to see a space relative humidity as well. So I must be doing something wrong here. But if I go back to service configuration, you can see you can actually read your range for 0 parts per million to 2,000 parts per million of what your sensor can read. And remember, we added an economizer. Once you make this change on this table, it's actually going to give you another set point on this unit configuration table, right? Because now we have economizer on here. You can see we got a couple more. So what we got was the DCV min position or the vent damper min position. This is my minimum economizer position. And then I have an economizer purge minimum position, a low stage fan economizer position, and a demand control ventilation max position. So those auto-generated once I put the economizer in the configuration mode. So you would want to adjust these set points to whatever you want locally on there. So other than that, that's basically the best way to get the unit started and configured so that it knows what you have here. What I want to do is, because I put it into Bacnet Schedule mode, I want to go to the Schedules tab and put a schedule on here. Okay. Right now you'll see there are no schedules. If I go to Configure, I want to add a schedule. This is only local to this controller, but I can add a schedule. You can do multiple types of schedules, right? You can do a normal schedule, which tells the unit go occupied from this time to this time. this time to this time. You can do a holiday schedule, which tells the unit go unoccupied from this time to this time. And you can do an override schedule, which will actually override both the holiday or the normal schedule based on what you have, what you put in there to go occupied. So if I do normal, I want to choose a weekly schedule so I can select the times of the week that I want it to go on. Let's say this is going to run Monday through Friday, so I check these boxes. This is my time that I'm actually scheduled right now. So I'm from 8 a.m. to 5. If I click on this yellow bar, I can actually just drag it and my times will adjust, or I can just type in whatever times I want. So I want to go 7 a.m. to 7 p.m. You can see my bar got a little bit longer. I hit OK. Now I just entered a schedule. If I look on it, I will have a schedule for all of these days, right? White equals occupied, gray equals unoccupied. Now if I look at my graphics, my unit should say local schedule occupied, okay? Right now I'm reading a space sensor failure because I don't have a space sensor wired in, but I can trick my unit to do that. To think that I have a space temperature sensor. So real quick, we're going to look at the last 4 tables here and try to squeak them in. I have my equipment tab. I want to click on my I/O points tab. What this stands for is your inputs and outputs physically into the controller. Okay. If I click on this, this shows me what my input values are reading for every input. We looked at before inputs 1, 2, 3, 4, 5. We could all adjust those and say what specifically that input is for, but there are specific inputs that are set in stone from the controller, okay? So for instance, input 6 is a supply air temperature and input 7 is an outdoor air temperature. You can check the manual, it'll tell you that, but that's just something I know off the top of my head. And you can actually see that I'm reading a space temperature value here, but I'm in space temperature shutdown alarm. What that means is I probably have the wrong space temperature configured, space temperature sensor, configured. So if I go to equipment configuration, unit configuration, I'm set up for a T55 sensor. I actually have an Spt sensor in there. So if I click Spt sensor, hit OK, wait for this to take here. Now I go to Spt, I go back to my graphic, I'm actually getting a space temperature reading now of 73.9, okay? But I'm still in shutdown mode because I have a supplier temperature sensor failure because I don't have one wired in. If I actually hit this little expandable button here, it will allow me to fake the unit to have an actual space supplier temperature reading. So I have this little checkbox where I can click lock value at. Let's say I want to lock this at 70 degrees. I hit OK. Now I'm going to think that I have a supplier temperature of 70 degrees. So my supplier error just disappeared because I think I have 70 degrees in that spot. Right? Now you can see I'm off. That's just a minimum off delay. Now because I'm occupied, I'm going into fan only. So my fan's going to turn on and I'm maintaining my set points. Okay? So if I wanted to test the unit now, I have all these values coming in. Let's say I wanted the heat to turn on. Well, right now I'm at 74 degrees in the space. I don't need any heat, right? I'm at 70 degrees heating set point, 76 cooling. If I hit this arrow, I can move my set points so that I want to fake the heating on, right? So if I go to 85 cooling and 77 heating, I need to make sure I maintain my minimum set point separation. I hit OK. Now if I give it a minute here, I'm going to go into heating mode. See how it switched to heating? Now you can see my gas stage went on. Okay? And with the 2-stage fan, I actually went into high heat because you need to go into high, I went into high fan because you need to go high fan for heat. Let's say I want to make sure the cooling runs, right? I can bump my set points back down to, let's say, 65 and 70. I hit OK. I've got my minimum run times built into the unit, right? So I still have to run my heating for a specific time, but I'm going to switch over from heating to cooling here in a minute. And once it does that, I don't have an outdoor air temperature reading right now, but I can fake it. And let's say it's 75 degrees. Now I'm going to go directly to DX cooling and not use my economizer cooling because I don't want to be economizing with 70-degree air. So you can see I switched to cooling. Now my compressor 1's on, okay? Let's say that I wanted to try to use my economizer air. If I switch this value down to 40 degrees, or 40, let's do 48 degrees, hit OK. Now I'm going to try to actually use economizer to cool my space. And you can see my economizer just fully opened. These controllers can do integrated economizer, so they can do economizing with compressors as long as the compressor is allowed to run on its outdoor lockout. But this is kind of the process that we would go through if we're testing one of these units, because obviously when you're commissioning one, your outdoor air is not always available to let you do heating and cooling, right? So you can go through and you can fake the control program and tell it, hey, I need to do heating now, I need to do cooling now, and you can watch it run and watch the relays engage and the unit turn on. Okay, so that's the general kind of basis of how you would go about testing the program with the controls contractor or with your mechanical contractor. Okay, so what you always want to do if you're faking stuff out is you always want to unlock it, because you never want to. If you lock a value on here, it's going to stay there until it's changed, right? So you do not want to be leaving these values locked, or else you're going to run into issues where the unit's not going to run. Okay, so I just told it I don't have outdoor air, I don't have supplier. Now I'm back in supply temp sensor failure. Okay, my fan has a minimum run time on here, so it'll probably run for 90 seconds and then shut off. Okay, but the graphic again is all standard, and you can see the fan actually spins, the heat actually turned on. So we're kind of running out of time here. There's kind of a lot of other features you can go into, but that's kind of just a broad overview of the commissioning that we go through when you set these guys up. Again, you really want to look at properties, equipment, and you go through configuration and set up what type of controller, what type of rooftop you're controlling, what type of sensors you have, and your set points. After that, it's good to go. Should be able to run. There are other ways to program these too. You can do it with the back view or virtual back view, which is really a whole nother class. And we will be offering classes on programming these, but kind of just wanted to give you guys a general training outline of how we go about programming these units. So with that, I'm going to put up a little slide here of the contacts that we have in our controls department. There are currently 5 of us in the controls department now, and all of us are available for help and support. You can see my contact information is on there. My coworker in Chicago would be Jim Rylowitz and Sam Cosgrove, who you can see down there at the bottom. But we also have 2 coworkers out in the Milwaukee location that are available for troubleshooting as well. That being said, I mean, if you guys have any questions or anything you want to go over, I'd be happy to set something up where we can talk about it, or I can give you more information. I'm not seeing any questions, but I guess we'd kind of like your feedback of what you thought. I know we're trying to cram a lot of this. I mean, trying to do the actual programming of these is a little bit more complicated, and there's a lot to it, so I kind of just brushed through as fast as I could. But if you guys could let us know what you actually liked about it or what you didn't like, or if you want more of these for different types of controllers, we'd be happy to help you and set some of those up. It's just this is the first one we've done like this, so we wanted to see how it goes and what you guys thought. So feel free to let us know. I think just got a question. List price on Field Assistant. I think sell price is around $250. That includes the cable to connect and the software for the laptop. And that software can be used on as many laptops as you want, but you only get 1 cable on there. So that cable you need to plug in. So again, we have our contact information. You can call us with any questions or email us. Feel free anytime. But other than that, I think we're going to wrap up here. Got another question here. Field Assistant is currently not Mac compatible. That is a good question. The new version of Field Assistant, which is scheduled to come out in August, will be compatible with Safari, Google Chrome, and Mozilla Firefox. So once that happens, we will make it available to you and let you know, and you will be able to use it with Macs, but currently it is unavailable. Has to run through Internet Explorer. So, sorry I ran a little bit late, kind of tried to cram a lot in there, but let us know what you guys thought, and if you have any questions, please feel free to give us a call. Thank you.